Okay, this is the page 2 of our Unit 2 assignment. So we've got question 6, convert 92 centimeters to the nearest tenth of an inch. So we're going from centimeters to inches. Take 92 centimeters, multiply by a unit fraction, cancel out centimeters, go to inches, centimeter and centimeter cancels. I'll look it up, and 1 centimeter is 1 inch is 2.54 centimeters. So 92 divided by 2.54 is 36.2 inches. So we choose B. Question 7, how long is 5'9" in meters? So for 5'9", we can either change everything to inches first or everything to feet first, or do 2 individual conversions. I'm going to change everything into inches this time. So 5 feet times, I'm going to go away from feet and into inches. So 1 foot has 12 inches. 5 feet times 12 inches per foot. Foot and foot will cancel. And that's 60 inches. So this is 60 inches. And this is 9 inches. So altogether, this is 69 inches. So if we have 69 inches, we want to convert into meters. We'll just do the same idea. Unit fraction to convert. For inches and meters, we don't have a direct conversion on our formula sheet, but we do have centimeters. So we'll have to do 2 steps here. So we know 1 inch is 2.54 centimeters long. Inch and inch can cancel. And so we get converted into centimeters. This is 175 centimeters. And then we convert centimeters into inches, which would be 1.75, sorry, not inches, into meters, which would be 1.75 meters. We could also do this in 1 step, where we just use another unit fraction right next to it. And we go away from centimeters, so I can cancel that out and replace it with meters. And 1 meter is 100 centimeters. That just shows our work all in one line, which is nice. So 6.95 times 2.54 divided by 100 is 1.75 meters, which is C. Question 8, Fiona is running a 26-mile marathon. Fiona can average 10 kilometers per hour. How long will it take her to complete this marathon to the nearest minute? So we either convert the miles to kilometers and then compare it against her speed, or we convert her speed in kilometers an hour into miles per hour. It doesn't really matter which one. I'm going to convert miles into kilometers. So if we take 26 miles and we multiply it by 1.6 kilometers per mile, then miles and miles can cancel, and we get how many kilometers? Almost 42. 41.84 kilometers. Now we know how far she's going in kilometers, and we can compare it against her speed. So we take our 41.84 kilometers, and we also have this unit in kilometers per hour. We have 10 kilometers per hour. So if we did this, if we multiplied by 10 kilometers per hour, we would end up with a unit of kilometers squared over hour, and that's just not right. So instead of multiplying by this fraction, 10 kilometers per hour, it looks like we're going to have to divide by it. So if we put these the other way around, if I flopped it so that I had kilometers down here and hours up here, then I'd be able to cancel. So in 1 hour, she can run 10 kilometers. So if we're doing it like this, 41.84 times 1 hour over 10 kilometers is 4.184 hours, which is great if you have a decimal clock, but we don't. 0.184 hours we need to change into minutes. So we know it's definitely 4 hours. So that bit there and that bit there, that's good. C and A, no way, they start at 2 hours. The question is 0.184 hours. How many minutes is that? So if I take 0.184 hours, and I'll just give it an H, and I want to convert that into minutes. I want to multiply by a unit fraction that has the same value top and bottom. I want to go from hour to minute, and 1 hour is 60 minutes. So hour and hour will cancel, and we'll be left with minutes. And 0.184 times 60 is going to be about 11 minutes. So that should be B. Yeah, 11.04 minutes, so that's B. Be really careful on questions like that one, because this 4 hours 19 minutes, it really looks like the 19 should just be a rounded off version of 0.184. This question was a little bit nice to you, because if you did round 0.184, you get 18 minutes. And that should be maybe enough of a clue that, oh, maybe I missed something, maybe I missed a detail. Why doesn't this quite work? In multiple choice, we often have to pick the best answer, but that doesn't mean that being close isn't a reason to stop and think about what's going on. Number 9, Monica's putting a rectangular patio in her yard. Patio stones come in squares measuring 1 by 1 foot. She wants the dimensions of the patio to be 8 stones by 8 stones. What will the area of the patio be to the nearest hundredth of a square meter? So first, what's the area in square feet? It's 48 square feet, 6 times 8, right? 6 stones by 8 stones. So the area initially we can say is 8 feet by 6 feet, which is 48 square feet. But we have to convert 48 square feet into square meters. So it's a square unit. I'm going to make 2 conversions. I'm going to get rid of feet both times to get rid of both of those feet in the exponent there. And I'm going to replace it with how many meters per foot. So I think we did this the other day. It was 0.3048 meters per foot. 0.3048 meters for every foot. So we multiply by each one. These 2 feet cancel out with these 2. We end left with meters squared. And 48 times 0.3 times 0.3 again is going to be 4 and a bit, 4.46 square meters. That's E. Got 2 more questions on this page. We've got the school gymnasium floor needs to be resurfaced. Hardwood flooring costs $5.75 per square foot plus $2.25 per square foot for installation. Gym measures 67 by 66 meters. At this rate, how much will it cost to buy and install the hardwood flooring to the nearest dollar? So we need to figure out the cost for the stuff and the cost for the installation. So they're both costs per square foot. So we could just look at the overall cost. We could take $5.75. Oops, that's not a 5. Come on. $5.75 per square foot, and we add up another $2.25 per square foot. So these are the costs per square foot of insulation, hardwood floor and the installation. So altogether, it's $8 per square foot to install this stuff for the material and the installation fee. The area of the floor is 67 by 66 meters. And 67 by 66 meters is 4422 square meters. And now that we have how many square meters, we just need to, well, we need to do two more things. We need to convert it into square feet. So if I take my 4422 square meters and I want to convert it to square feet, I can take my 4422 meters squared, multiply it by 2 unit fractions to get rid of meters both times, and replace with feet both times. And I can say that each meter is 3.29 feet. I think that's what's on your formula sheet there. So 3.29. Gonna have to rewrite that. 3.29. Good thing there's audio here, so you don't have to rely entirely on my writing. And meters squared cancels out with this and this. And this is 478. Hang on, I just pushed the wrong button on my calculator. Got to redo. 47596.8. 0.85, I suppose. And this is the unit square feet. This is how much area in square feet. And we need to do one more step. And this last step here is going to be, I don't know, I'll have to shove it into this corner. We have to find out the actual cost. So if we take 47596.85 square feet, can we multiply it by $8 per square foot? Square feet and square feet will cancel, and we're left with just the unit dollar, which is great. And if we multiply it by 8, we get 380774.8, which in this case, 380776 is one where we have to take the next best or the best possible choice. It's likely that the person using this key used 3.2808 square feet, which I think is the actual value. So my abbreviation writing 3.29 in there, which is what I remembered off the top of my head, was a bad move. So this number here of the actual square footage is slightly off because I used 3.29 instead of looking up on the formula sheet, on your formula sheet, what value to use. So this one here, 380774 is what I got, but 776 would be actually correct. Number 11, steamroller is flattening a new section of pavement. The diameter of the cylindrical roller is 6 feet and the face is 8 feet 2. So we have a cylinder that we can pretend to draw. So the steamroller has a cylinder. When it rolls, the part that is touching the ground is just this part, not the edges. So this face here, this circle face here, and the circle face on the other side, they don't touch the ground. So we're just looking for the area of the rectangle that wraps around this cylinder. So we need to find our area of that rectangle, and we know that the area of that rectangle, so for the entire cylinder it would be 2 pi r squared plus 2 pi r h, but we're not looking at these pieces, they don't touch the ground, so it's just 2 pi r h. We know r is 3 feet, because if they tell us the diameter is 6, then radius is going to be exactly half. We know the height in feet and inches, so we need to make this into just feet, which is really easy to do, actually. So the height, I'll just write it up over here, the height is 8 2/12 of a foot. So 8 2/12, I didn't have to think much to put that as a unit there, because there are 12 inches in every foot, and if I want to convert inches to feet, I'm just dividing by 12. So for this one, I have 2 times pi times 3 feet times 8 2/12 feet. Feet goes in the bracket, come on there. So 8 2/12, which is just 8 1/6, but whatever, times 3 times 2 times pi, we get 153.86 about. And our unit is feet times feet, which is great. We're looking for an area, square feet. So it looks like 154 is our closest bet there, C. Just before I finish off with this page, I just want to mention that for number 10 and for number 9, I did it on number 8, but not on 10 and 9. For number 9 and 10, you could have gone about this another way, which I actually prefer. I don't know why I did it this way today, but would be to change 8 feet and 6 feet into meters first, and then just when you get the area, it's already in square meters. And for number 10, change these meters into feet just at the beginning, and do everything per foot. I prefer to take linear measurements that aren't square or cubed, and convert those before I'm dealing with anything else that's squared or cubed. Just, it's simpler to do, and I like to get it out of the way at the beginning. This was a long video. Hopefully the next page will be a bit faster.